Yeah, good morning, everyone. We just continue of the last class, so we'll mainly focus is the interview. So yesterday we covered latch of shielding and current mirror concept. And WP means why we need to add dummy. So today we just extension of this current mirror. So in the op-amp, so op-amp is consist of current mirror and differential pair. So I'll just draw the op-amp diagram. Anyhow, this will be clearly explained. Again, new op-amp will be discussed. So no need to worry. When you do the layout, I will explain little bit more again. But for interview purpose, whatever they will ask, that I am covering. This is just a single stage op-amp. If you connected, okay, a little bit. So this diagram is a single stage op-amp. The single stage, double stage, how I will define? Okay, let you assume this is your input. V1, V2. This is supply VDD, VSS. This is your V out. So normal op-amp diagram, you see V1, V2, V out, VDD, VSS. Okay, so this is one stage. Up to this another stage. The stage depends upon the gain. If your two gain is multiplier, a double stage. So this is one A1 will be creating. This is A2. So this gain thing actually this is come under the analog design course. So no need to worry. I'll tell you this once you discuss. If I discuss, that is no use now. That will take only 1 hour to discuss how this gain calculation Okay, so I'll discuss definitely. And for analog layout interview, they will not ask. This is a single choice. So current mirror is PMOS current mirror. This is a PMOS current mirror. How to identify gate drain sorted? VGS1 equal to VGS2. Similarly here, two current mirror. This is first stage is current mirror. This is also a current mirror. And this V1, V2 is the differential pair. Differential means voltage will be difference here. V1 minus V2. Up to now, any doubt? Okay. So when you, it's what they interview they ask, they will give you some multiplier. Okay. So they will give you, they will write MO equal to 2, 3, 4. The multiplier means they are connected in parallel. So how to do layouts? And if you see current mirror, VT will be same. Even the differential also VT remains same. So to make VT remain same, what is the condition we need to? The concept come matching. So always remember for matching device is for current mirror or differential pair, generally we will use matching because their VT, wherever the VT variation will be occur, their matching will be required. So matching concept is come from this. To avoid mismatch between VT variation, we need matching. This is the one cause. So any mismatch means another mismatch will be process variation. Process means fabrication variation. Like due to ion implant, this is not your hand. So this is like VT ion implantation, mesh, etching concept, and photolithography. These are the process variation. Due to the variation, some issue will be affected. So matching is divided into two types. So this PPT also I'll share you today. Maybe open PPT is there. So this is single stage OPA. So PT variation is important. Everything I cover here matching. So process variation, lithography, photolithography, rotation, temperature gradient on the chip. So many points are there. Okay, so matching are divided into two types. So how to this number of multiplier is there. So how we will place in the layout. That is our discussion. So first point is interdigitization. Second matching is common center. Okay. So interdigitization matching is done by one axis, means either x or y. This is called one dimension. So either means suppose a equal to 4. I'll write a like this. So only one row or one column. That is called one dimension. But common centered is two dimension. Understand? This is basic difference. And who is accurate more matching is common centered. The matching will be perfect because this is one direction, so we cannot do all direction matching. So common centered is a highly accurate matching. So I'll give you one example. Suppose A equal to 8, B equal to 8. So you need to do interdivision matching. So how? Interdivision, just the distance between A to B, any device, so A to B, suppose C are there, A to B, C, distance will be same. So that your length will be same, B2 will be remain same. This A to A, every A to A distance will remain same. B to B means adjacent design, not in this B to this B. Adjacent B remains same distance. So this is normal matching. This is called interdivision. Second, we need to do common centered. So common centered, because this is a critical matching, so we have to follow certain rule. The first rule is it should be symmetric about x and y axis. So symmetric about x and y axis, how it will be? If you maintain first quadrant equal to third quadrant, second quadrant equal to fourth quadrant. Whatever the element will be there, so it will be same. This is the main. Second point, it should be compactness. Compactness means it should be rectangular or square shape. All 4 points I have in this PPT, it is there. Coincident, symmetric, dispersion, and compactness. The dispersion means, so you have to arrange how perfectly, as much as. Okay, so I'll give you example, you will understand better. So which one is better dispersed? From this example, you will find. So A equal to 8, B equal to 8. So So A equal to 4, B equal to 4. Total 8 number device. So first quadrant equal to third quadrant, second quadrant equal to fourth quadrant. So this is also a common sense match. Next, same thing. In this example, so A dispersion, this is called dispersion mode. Even this one also first quadrant equal to third quadrant. So A dispersion means every direction you will see this is only matching only one device. So A is not arranged perfectly, but here it will be arranged. But in which case it will be preferred? This is a layout will be easy in this case because all are together you can keep nearer by near, but here routing will be little bit difficult. But even if it difficult, the dispersion is more. So this is the preference one. Understand? Dispersion. This is how you disperse perfectly. So all direction. If it is some another row also, you can arrange. If more events, so this is less number of you arrange like this. Even 2 row, even you can do 4 row also. 8, 8, 16 days. Okay, somebody tell I will do. This is the one example I given. There are many possible you can do. If you count A equal to 8, B equal to 8. This is also a common center. So now dispersion will be more. So which one before you can tell. As per your suppose area is vacant in the horizontal, you can do this one. If your area is vacant vertical like this also you can. But this is the dispersion is more perfect. Understand? Any doubt with this very important topic? If anybody having doubt, let me know.
Hello.
Yeah.
So, sir, there is A equal to 8 and B equal to 8. Then we can do like this. And if A equal to 8 and B equal to 12 or less or more, then how can we arrange?
Yeah. So any number you can arrange. Suppose even odd number also like A equal to 3,
Right.
B equal to 4. So before done, add a dummy to make this completion of compactment. So dummy shape will be same as A in this case. The width length of the device of the A remains same. Understand or any doubt?
Okay, so understand.
Hello, sir.
Yeah.
Sir, can you do for like A equal to 3 and B equal to 5? Like that, in that way, we can add so many dummies, like 2 or more dummies. So how can we place the dummy according to the common central rules?
A equal to 3, B equal to 5.
Uh-huh.
So 5 is done, but it is not a common centroid. So what we will do here, our dummy for A okay, B5 is there. So you can press here. So generally add dummy in the side only. Okay. Okay, for dummy I'm just writing D because some people will confuse. D, this is B, so you need 4 dummy. This
For
is one.
dummy.
4 dummy, why? Because this is first current equal to second current. Second current equal to third current. So dummy here, dummy 1 dummy required for A. Here 1 dummy for B. So this dummy also for making this compact mix. This is one suggestion, or we can try. So this is
Sir,
how, yeah, tell.
in third quadrant, why you can't A, B, D? You can dummy put over here A after B, A, B, D.
This is first, second, third. Okay.
Hmm. Hmm.
You are telling
A,
what?
B, D we can't take. A, B, D in third quadrant.
Instead of this, you are telling I need to write A B D.
Why we can't take like that?
A B D.
Hmm.
Okay. So what is the wrong? This okay. So first to understand this point. One point people are confusing. So this is like 1. So 1 coordinate. So this is x coordinate. This is y coordinate. So its value is, as for this example, this is your B. Okay. So it is opposite coordinate means what? First coordinate opposite. So this is B coordinate is -1. Oh, sorry, 1 1 1. So in the same quadrant, first third quadrant, it should be -1 and -1. Understand? So it should be see same B value. But as per your point, if it is you taken D, its coordinate is what? You're getting the point? This should be same as this one. See, this coordinate is -1 -1. This coordinate is 1 and 1. This will be common centered. If you are saying it should be B here. Understand? But if you are taking B here, what is the coordinate? X axis -3, y axis -1. So B is present here. So this is wrong. Understood or not? Or very simple way you can tell, if this is BAD, this should be BAD. So you can compare. So -3 x, this is x axis, this is y axis. So -3, -1. The coordinate is D here. So 3 and 1, x and 1, it should see same. D should present here. 2, 1 axis coordinate. You are getting or not? Somebody ask. Or for other, you got the point?
Yes, sir. Yes, got it.
Okay. See, that's why everywhere. See, A means this should be same. This should be same. This should be same. So here B means your dummy. And 2 point matching to only not first point, second point. When you do layout, the poly pitch, poly to poly spacing remains same. So don't do one device is sharing, and even they will ask into one device you do share, it's another drain it didn't share. So what will happen? The poly sharing is not done. You can see the example also layout. So poly to poly distance remains same. This is the two main factor required for matching. Okay. Yeah, any doubt in the matching? So out of this, which one correct?
The 4.
Okay. Any other answer?
4, sir.
Oh, what about 3? Both these two are correct. What is it? This is CC, correct? CC. A, C. This BA is not correct. AB not correct. Okay, so next will be EM already cover. Okay, this is the interview. EMI is also asking. I think those who attended, I think for 1 hour I have taken. I told you to watch this recorded class. So electromigration, this concept comes from like your household. You are using a charging anything like your laptop. You need a charger. Your power supply is giving. So that you are using some wire. So even chip also needs a conductor like metal. Everything that you are using. So if this metal, take an example, it will carry maximum 1 milliampere current. Depends upon width. So width is having 0.2 micrometer. Or I'll give you example. In this technology we need to follow this current density 2 milliampere 1 micrometer. This is not example, this is correct one. So 1 micrometer width will carry maximum 2 milliampere. But if you supply 4 milliampere, so what is the width you require? What is how much micrometer?
2 micro.
Correct. 2 micrometer. But suddenly you did the layout with 1 micrometer. You didn't calculate this one and you given 1 micrometer. The current is 4 milliampere. Due to this, you will find EM violation. Actually, for EM check, one tool also there. So when you do a real time EM violation check also you can do. So that time this run you have to go through. It will not pass. It is some company they are not following, so you have to take care from starting. Okay, so this is how it is important. So let's come to our definition. So EM means electromigration. So migration of electron from one position to another position. So how it will be migrate? you know this is a metal. So metal is conductor. Conductor means inside that atoms will be there. So these are atoms. It will be arranged in the crystal structure. Okay, so these are the atoms. They are tightly packed. In conductor it will be, insulator it will be very less. The atoms are tightly packed. Or this is, so when you apply some voltage here, it will be moved, but this voltage continuously you are applying. Continuously means it is positive charge and here negative charges are eliminating for long period of time. So 2 point you have to remember. So when it will be eliminate continuous period of time, it will be DC. DC means direct current or unidirectional. Unidirectional one direction it will be flow. For AC it is alternating current. So at that case it will not never happen. So when unidirectional current passes for long period of time, this is the 2 point. Even in this PPT also I have clearly mentioned these 2 points. Unidirectional current, long period of time. So what will happen? These are called ions. So positive ions, negative ions. So ion collide with atoms. So due to the collide, so the structure of atom will be changed. So this structure when it tightly packed, it might be moved to the atoms. It will be bent. If you see that is sparking for continuous in your household or you're seeing outside, the sparking will be continuously. What will happen if there is a two wire will be there? It will come this wire. It will be short. Then suddenly spark will occur. Your really power supply will gone. So same thing here also. When you do this is a take example of a M1. Another M1 also passing with minimum DRC you maintain. So what are this structure of the atoms will be chance to collide with this atom. Okay, so when this collide, so what will happen? This is a metal, this is another metal. It will be short. This short is called in technical in EMA term that is called hillock. Or another case will be occur. This is like a research at the time of they have seen for long period of time they are watching, and after watching they come to result this thing is happening. Second case, these atoms can be moved here. Means some area it will be vacant occur. These atoms are displaced. Due to displacement, so what will happen? There is a open circuit open, or there is called void of the atom system. That open circuit is called void. Means two atom is so conductor is a open circuit. Now even you pass a voltage, no current will flow. That case also will open. That is called void. Understood? Short circuit means hillock and open circuit void. So how to define? When a unidirectional supply applied to a conductor over a long period of time, Due to this, there is a short circuit and open circuit is created. That open circuit is called void, short circuit is Hillock. Due to this, the atom means the chip will not operate because the short circuit open circuit occur means what? The chip will be damaged. If one short circuit occur means also device will not operate. Understood? So if you would not see the diagram, this is not the actual PPT. Yeah, you can see the diagram now. If this is a metal, this is a metal. In between, insulator are there. So this is called Hillock. This is called void. So how to reduce? First point I told you, increase the width. So more width means, so as per your current rating, you have to place the width. Second point, metal stack. So this point metal stack means, this is I'll show you in the layout, metal stack. Then parallel routing, use more contact and via. Power mesh, length reduce. Okay, so what is this length reduce? All this thing I'll tell you now. So R is equal, this formula also every time they are asking, rho L by A. So rho is equal to length into area means width into thickness. And this rho by T is called sheet resistance, RSH. SS is for sheet resistance, length by W. So every metal they will give you sheet resistance and you will multiply the length and width. This depend upon your technology. Everything will, okay. So if resistance if length you reduce, resistance also reduce, then you can pass more current. So I equal to V by R. If you reduce, current will be more. Secondly, if you width increase, resistance reduce. Okay, current will be more. So more current you can pass. That is the thing, because this width, this is how you remember. From this formula you can tell 2-3 point. Parallel routing, more current. In parallel, current will be added. This is also common, the same point. Metal stack also is like, okay, I'll tell you metal stack, more via contact. This is like a parallel, you understand. So this is like a parallel. So current will be R. So this is 1 ampere, 1 ampere, 1 ampere. So all will be R. You will get 3 ampere. So this is the parallel routing also same. You can pass more routing. Okay, so metal stack, I'll give you the example. Okay, so you want to see metal stack. So metal stack means metal over with another metal. So this is M2. You draw M3. Same width it will be. If you use auto here, this one metal stack over M1 and M2, two metal are there. So this is the stack. So if you increase the stack, so you see there is more VR2 also there. So they are in, you can pass more current. So what is the equivalent resistance now? Not resistance. Total width will be double now. 0.5 is that, so it is take as a 1 ampere current because 0.5 plus. Understand? Suppose you can use M4 also over it, and you can use metal M2, M3, M4 metal stack. By using metal stack, you can pass more current and more via. If you use more via, what will happen? Resistance reduce because parallelly more via means we are using, suppose M2 and M3, we are using more via. So let us assume this resistance, contact resistance or via resistance is 6 ohm. Total 6 resistors are there. So if they all 6 ohm is parallel, what is the equivalent resistance? It will be 1 ohm. The resistance reduced means we can pass more current. Okay, more via or more contact we can have. So normally in the higher technology, minimum 2 VI you are taking. Okay. Any doubt? Just read this point. So how many is there for interview tomorrow? For Capgemini? Okay, I'll repeat antenna left only for layout dependent effect. Yesterday I already told, WP I told. Length of diffusion, just a diffusion length of the source and drain remains same. That is length of diffusion only. So how to avoid? Okay, let's take example. So this length of the diffusion should be same. Okay, if it is and another device are there. So in between what? SiO2 layer will be there. So due to this SiO2 layer, it can be this channel length will be reduced. Sorry, so source and drain length reduced. So what will happen? That time LOD effect will be occur. To avoid this LOD effect, if you use dummy in the side, you're getting this point. What I am trying to say. This is oxide layer. So you are adding oxide layer. Oxide layer is a, it can give you a force. So what will happen? This is the force. The trace effect will come. So it will be, so this is really reduced to 1.9, so about 2 micrometer reduced to 1.99 micrometer. Okay, so 1.9 micrometer passing the current, it will take only 1.9 micrometer, but you will design this circuit 2 micrometer. So what will happen? This is the damage. Damage means EM also will occur, many effect will be occur here. Okay, to avoid this, if you use a side dummy. Means you can share with this device and you will use dummy in the side. So these two are dummy. So if due to the force, the compress of this is up to this compress. Will it affect to active device? No. Understand? So that's why you will add dummy also for length of diffusion. So in this PPT also I have mentioned clearly. Say length of diffusion. If length is different, it will occur proportional to OD outside diffusion boundary. So length we add dummy both same. This is STI I covered yesterday, solid range isolation. WP also I have told. Okay, the main point is antenna. So antenna if I cover, here everything will be IR drop, just a drop. Like resistance, how we will calculate C resistance length in W. So you know the current and resistance. We can draw calculate the IR drop. Okay, so till now anybody any other doubt? Any interview question? I will complete antenna only. Before that, okay, no one having any question or
Hello.
yeah, Abhishek.
So this question, what is DRC and LVS differentiate these tools?
DRC LVS
Differentiate these tools.
differentiate.
Different.
Can you repeat the question?
What is DRC and LVS differentiate?
Okay. So DRC will be clean only the layout view. And it will be what is the full form design rule check. So whatever layout you draw, it will check only layout side. It has not linked in the schematic. But LVS is the link between schematic and layout. It will compare schematic and layout. So whatever the schematic present in the layout, it should be matched. But in the schematic, you did any other thing, even schematic also not there, you can run DRC. That is the point. You can cross check also. Suppose you didn't do have schematic, only layout view, you run DRC, it will be work, but LVS will not run. Without schematic, DRC can run, but LVS will not work. Second point. Third point, it will be compared between layout versus schematic. But DRC has no link on schematic. Okay, and why DRC is there? DRC is just a, it will check the devices or any metal having minimum rule is there or not. Okay, so certain rule as per technology we need to follow, because you cannot draw anything like blindly as per technology. So this is, you are doing 90 nanometer, as per their technology you have to follow certain rule. Okay.
Okay, sir.
Okay, so in interview also they are asking LVS error flow, means which error you have to clean first. So first clean sort error. This is very important point. Then go for net pin error. Third, net error. This is every interview they are asking this type of question. If you fourth, you can take mismatch error or device error or property also. This all will become one. This is your choice. Mismatch, property error, device mismatch error or property error. Both will become 4 by. I don't this you can, anything you can do. But these three are very important. One is sort error, pin error, net error. Understand? Next, ERC, electrical roll check. Actually, in the Virtuoso, we don't have this. You will find in the caliber. So, ERC is the part of LVS when your body is floating. Body, sorry, not only body. When suppose P mass is not connected, so supply is floating. That time ERC will find supply floating means your VDS, VDD, and VSS or ground. VSS are floating, is not connected. That time you will find this error. That's called ERC error. Electrical roll check error. Understand or okay, what is this sort error? Sort error means when two pin is sorted. And they called sort error you will find. When one pin, one net is sorted, you will find in pin error. Oh, sorry, net error. But when two pin is sorted, that time you will get in the sort error. Understand or any doubt? Okay. Yeah, before that, one property, because these are interview question only. Today we are discussing DFM issue. A design for manufacturability. So what is DFM? So when you go to your fabrication, you need to follow certain DFM rule. DFM first point is density. So what is density via enclosure? So density means You have two type density. One is mean density, another is max density. So minimum you have to follow. Suppose M1, this will be common to metal density, oxide density, poly density. Okay. So for certain rule, so like minimum 30% you will do, maximum 80%. Means how it will be calculated. Certain area is there, so depends upon technology. So this much area you have to see minimum metal should be there 80%. Sorry, minimum 30%, maximum 81%. But don't completely fill by only M1 100%. 100% area you will not cover by M1. That will come under maximum density. How to clean? You have to reduce this metal. You have to delete some metal. For minimum density, you have to add some metal. You got the point? This is very easy one. But in real time, in this technology, you don't have density, clean. Okay. The next is via enclosure error. So you are also doing. So you these are the parts of DFM. See, DRC is just same thing. It will be DFM also commander. This is just an extra version. Means some technology you have to follow DFM. I mean DRC how you are running, DFM also option is there. How to run same way. Via enclosure error, antenna error you will run. Contact enclosure. So this type of, suppose you have two metal. Okay, I'll give you example. Contact or via enclosure, how you will do? Okay, you will place a contact in between them. But somebody is asking contact they are using like this, so this is not the correct way. This much big contact. So this will be commander, or you are using some very small. This size is 0.5 micrometer. But you are using very small contact, because contact also will carry current. You are using this much contact. Okay, so EM also will pay. So this is will be caught in the DFM stage. Contact enclosure, density error, antenna error. So now we'll discuss antenna error. Actually, I have PPT also. See antenna effect. minimum area, density gradient, contact enclosure. So this is how also I explain. Metal via contact and then you are not supposed to draw like, and then metal to metal spacing. This 4-5 error you can tell, that is fine. Density, minimum area, like some metal you are taking minimum PL, NL, so that is also come under DFN. Okay, so this TPT I will I'll share it. Okay, so now come to antenna. So antenna effect is important. So before that, one interview question. Forget our current direction. That is I1, I2, I3, I4. In which case EM will occur? This is the interview question. Just take some time. Any answer? So you have four options: I1, I2, I3, I4. So in which current you can tell only name and why. I am giving a clue. It should be unidirectional. Just find which one is unidirectional. That will cause your EM.
So I4.
No, I for wrong answer.
I3 sir.
I3 wrong answer. My question is which current will cause EM?
I1, sir. I1.
I1 is not correct.
So
Current
I1,
I1 plus I4.
I1 to I2.
Yeah, I1 and I2 both will be. The I4 is a gate current. Gate will be open circuit. How current will flow? So this is 0. Always gate current will be 0. So this is a neglect. Then come to I1, I2, I3. So unidirectional means only one direction. So this I1 current, only direction is this one. If this PMOS will be on. If NMOS on, I2 current only this direction. It will never current flow upward direction. Why? Because this is 0 volt. This is high voltage. Current only is from high potential to low potential. So it will never current flow like opposite direction. Here the same thing. This is high potential, this is low potential. Two things is clear. Then come to I3. I3, so when PMOS on, it will be flow like this. When NMOS on, this will be flow like this. Okay. So this is called your bidirectional current. By bidirectional means plus or minus. One direction, opposite. So when plus or minus will be there, EM will not occur. EM will occur only unidirectional. Means one direction. So I1 and I2. So got the answer or anybody having doubt? Okay. Antenna effect. So antenna is a long net. So antenna in your hometown, previously they are using antenna. So antenna is a long wire or long net. That term is coming from there. So in the VLSI also, so first to understand this. So when your gate connected to long net, that time will occur. But what is in long net? What is happening? It is occur in during fabrication. So fabrication, when it will occur, you completed layout, everything you done, then go to fabrication. They will manufacture first which layer, step by step, like piece of thread, annual, then implant, poly implant, activity also will be over, then go for contact and metallization. So when they will do metallization. That time suppose M1 they did, then M2 they will do in between Si2 layer. So Si2 layer also they will do. So at the time of metallization, what will happen? One effect, itching. Itching also, every step they will do itching. Itching is removing Si2 layer. Okay, so they will feel by metal. So at the time of itching, so what will happen? Itching is two types. One is dry itching, another is wet itching. So generally, dry itching they will use because they will be no liquid metal. So liquid metal, wet itching means they will use hydrochloric acid. But dry itching, they will use plasma. So what is this plasma? Plasma is a like ion, solid, liquid, gaseous. So when you boil again with gaseous, another form is called plasma. See, plasma, one type of gas they will use for removing SiO2 air. So plasma etching. Actually, if you see the high speed stream of glow discharge, one type of stream. So that time when you boil liquid, it will be gas. Then again you more heat water with a long high temperature, so it will be become steam. Which is like etching stress. It can either be charged or ion. So it will be charges will be there. Lots of charges will be there. Charges mean ions will be there when they will do plasma etching, and these ions may be positive or negative. This because this is a conductor, so it will be come to get more and more charges will be there. So it will be try to enter your gate oxide. The gate will be sorted, so device will be born. Because there is no path will be there, so it will be entered to here. So it will damage your gate oxide. This is the definition of antenna effect. So come to our definition. So first, when they are asking what is antenna effect, you will tell during the fabrication process, large amount of charge induced in the plasma exchange. And this, so if at that time, if it is long net, is connected to poly. Okay, so this, what will happen that time? The large number of conducting may will act as antenna. That net will be act as a antenna, will receive induced charge of the fabrication. I mean, due to the plasma is whatever the charge are induced, that will be received. This is extra number of charges. This gate is not able to handle because this gate always it is made of thin gate. Okay, thin gate means it is very thin layer. So if more charges are there, it will not able to handle. So it damage the thin gate oxide that is called antenna. Understood or any having doubt? Okay, to avoid antenna effect, we need to process antenna ratio, jumper, and antenna diode. What is antenna ratio? Antenna ratio means for every technology there is a value antenna ratio. Antenna ratio formula is metal area by gate area. So in the layout you will find on the length and width. Okay, this length is connected to gate, that is called area. Length and width multiply, that is called area. Gate area also, gate having length and width, you will find gate area. if you divided that ratio for each technology they are given. Suppose in this technology you will find 1000. So if it is less than 1000, it will not cause antenna effect. But if it is greater than 1000, it will cause antenna. Okay. So why greater than? Because metal area will more. A metal area more means length will be more. Width has certain limit. You cannot increase width up to 20 micrometer, 30 micrometer. There is you will check in the DRC also. There is a certain limit also there. So you will play with length only. So this length more means it will be coming under here long net. Okay, so if you have maintained less length, it will be up. You can save antenna error. I'll take a example. Which one is the antenna error? So this is length, this is height of the poly. So metal area, you know. Second example, that is nanometer only. Okay, so antenna ratio for this technology is 5 nanometer, 10 nanometer, and antenna ratio is 50. Let's take example. So out of this, which one will be cause antenna error? Antenna ratio is 50.
So second.
I know. So answer is both will be Koch antimatter. Why antenna ratio is calculated? Metal area by gate area. So 2200 into 10. Metal area gate area means 4 into 5. Gate ratio is 100, which is greater than 50. In this example, metal area 1000 into 10 divided by 10 into 10. This answer is 100. So both have 100 is greater than 50, so both will cause antimatter. Understood or any doubt? This type of inter question nowadays they are asking. Okay, so how to reduce? You can reduce the metal area. This is the first step. Second step, if metal you are not able to reduce, means suppose this you connected this some, it might be connected to some devices. This is your PMOS. This is fixed. You are not able to reduce. So what will be next step? How to reduce this antenna error? Is jumper. So what is this jumper? Jumper means jumping from one position. But it means jump. So similarly here layout, you will jump. But before that jumper, so first you understand what is happening in the fabrication. Or like a suppose you are to build a fourth floor house. So you have to complete first floor, and then you will go for second floor, then third floor, then fourth floor. You're getting third floor, fourth floor. This is just, if completing means everything is over. You connected brick, rod, everything, plaster, all these things left. But second floor you completed, then you will be start the fourth floor, third floor, then fourth floor, like that. Similarly here also, you connected gate. And this is your M2. Okay, so you are not able to change anything. So what you are jumping? Jumper means how, as you understand how it is jumper. You will chop this metal, then you will use a higher metal. This is the important point. Next, adjacent higher metal. Don't use M4, M3 metal you will use. Like your first floor is completed, you will join for second floor. Same layout also, you will use M3 metal. Okay, and it will be placed nearer to your device. Okay, now you can ask me why you are not using M1. This jumper thing, why you are using always higher metal? This is the interview question. Understood?
If we use the lower metal, maybe resistance in that path will increase.
No.
If we use the lower metal in the fabrication process, lower metal will be fabricated first, then the higher metal. So that's why we use.
Yeah, this is somewhat correct. That's why I give an example. Like first floor is fabricate, then you will go for second floor. Like second floor fabricate, third floor will fabricate. So in fabrication, M1 already fabricate. The fabricate means your charges are present here, M2 layer. This is already fabricate. So these charges, if you use lower metal, these charges having path. Because these charges only causing your damage to get. Path means here also it is coming. It will go. And your antenna effect we are not saving. So if you calculate, this will cause your damage here and can get outside. But if you are using higher metal, so if your higher metal means M3. So now if M3 you started means M2 means it is perfect. It is fabrication is completed. So charges is not present here. Charges is present here. This point you have to note it. So this charges is present here. So if you calculate metal area by antenna ratio, if you calculate only this up to this, you will be calculating. So it will be definitely come. And if you place nearby jumper, this definitely the metal area by gate area it will be less. But if you understood or any doubt till now? And what is for fabrication? One process called deionization. deionization means how to remove any charges will be there. So we'll use like positive charges is there. So like magnet, if you put the charge, you're able to see my screen. Okay. So what I am trying to say, M2 already completed. So already completed means it is having no charges. So charges only the next higher metal. But if you do M1, this is already fabricated. Now charges only in the higher metal, which have this process is not completed. So charges is present here on. Understand? So now if you call and ratio only this much layer, so this is no use. And it is having path also there. Understood or anybody having doubt? D Gururaj, you got the point?
Yes, sir.
Yeah, so this is the second, this is the step by word. First antenna ratio you have to reduce by manually. Metal area by gate area. If it is not there, our jumper. If jumper is not there, third process is called antenna diode. This antenna diode I already did. Okay, so those are new people. This if positive charge, negative charge depends upon both. So I'll compare both charges and antenna diode how will be connected. So this is like a bypass. So charges are, let's take example positive charges. This is your NMOS, PMOS. So more positive charges. So like you told 0 to 5 volt. Suppose 7 volt is more positive, more negative charges is minus. So if more positive charges will be gone, this is how it is connected. So this body is connected to ground. Okay, this is VSS. For NMOS, you will connect it like this. For PMOS, you will connect it like this. Why I will tell you. So this more positive charges is coming. It will be enter here. It will be enter here. So this you have to connect it to VDD. So VDD is 5 volt. This is having 7 volt. So what will happen? So charges will be, this will be forward bias. Charges will be entered to substrate. So your device will be safe. Next coin. Next point is if it is negative charges is going. See 1 to 0 to 5 any voltage will not damage this charge. More charges only come, that time it will be effective. So let us assume -1 volt is going. So this is your 0. So anode potential greater than cathode potential. So this diode will be forward bias, it will be entered to your P substrate. This is your NOD. Understood? More negative charges mean this will be turned on, it will be safe. This device will not damage. More positive charges will come, it will damage this device. So you will connect it So this diode will be connected like this diode will be connected like this. So you can tell NMOS this diode or PMOS this diode. Understood? So whatever topic yesterday and today, whatever topic I cover, just revise it 2 times. Your 90% interview will be there, and some project will till now started. If they are asking, that is okay, but 90% question will be come under this. Okay. Last topic is you can tell standards, how to calculate standard cell height. So always remember, if you maintain some height fix, what will happen? All divide, like standard cell means none nor all. So your routing will be easy. So your if you do an NAND gate also same height. Okay, how to calculate standard cell? So the formula is there. Number of track minus 1 into pitch. Okay, so let assume your devices, one is PMOS, one is NMOS. This is your tap. So track means just a metal drawing path. So you draw, these are called track. Here only you will do metal track, means you will draw metal only in above that layer on track. Track just a virtual layer. So how many metal? Total 6 metal you draw. So height of a standard cell means your center to center of P tap to N tap. This distance. So this is distance how to measure. And what is track distance? Let us assume 0.1. Pitch means the center to center adjacent metal. Okay, the distance between two adjacent metal, but that is the center point. So you can define pitch is a distance between of a middle point of a two adjacent metal. Middle point or center point you can tell. So this is the center point, this is the center point. What is the distance is? Let us assume distance is 0.2. Okay. This 0.2, this point, 0.2 distance, and metal width distance is 0.1. I forgot about metal width also not required. I am telling only point pitch you know means you can find the standard cell height. So what is the formula? Number of track. Track how many track? 3 into 6. So 6 minus 1 into pitch. Pitch you go 0.2. So 5 into 0.2, 1 micrometer. So whatever I am telling it is correct or not, I will check. So you will check. This is the point, pitch is 0.2. Here to here 0.2. 0.2. Here to here 0.2. Here to here 0.2. We add all 0.2, 1 micrometer. Means here to here distance, if you measure manually also, you will get 1 micrometer. Okay. This is the standard cell height. Okay, so that's all today. Any doubt? So all the best for tomorrow interview.
So I have a one doubt. In the op amp, we are using the current mirror, right? For that one, I believe a common center matching we are using. Why not
No,
we?
no, for current mirror.
Yeah.
Always use current mirror. Sorry, dip pair is the common center matching. Okay, for current mirror generally sometimes use interdifferentiation or no matching. No matching means normal matching. Normal matching understood. So, okay, let I give you example. Only you do matching. It will not come under. Suppose A equal to 1, B equal to 2. This is the current mirror. Okay, or you can tell C also 2. So don't tell. It is the one option never used for current mirror as a common center. So common center matching only for deep pair. Okay, current mirror sometimes you if some cases will be interdifferentiation or some cases that is called normal matching. Normal matching means this is your direct current. This current should be same as other current. Theoretical, just understand this I equal to I1 plus I2. Which one is a direct gate and drain connected? This device is called diode connected also. This is the your reference current. Understood?
Yes, sir.
The reference current I will place center. I will place this device B here, C here, C here. Can you tell is this coming under any matching?
Interdigitization.
Interdivison also not there. Interdivison how it will be? CBA, CB. You have to add some term. Like C to C distance same, B to B distance same, then C to dummy. That is called interdifferentiation. Understood?
Yes, sir.
But we are doing this is not interdifferentiation. This is matching. We are doing so all the distance which this is A you taken as a center because this is the reference current. From A to B distance same, A to C distance same. So if you are maintaining the automatically the B current and C current will be same. If you maintain because this is only gate drain sorted that will be acted as a even sometimes this term is called diode connected device. Diode connect device placed in the center and that you take as a reference. This is sometimes if it is suppose in this case if A equal to 2 or you can tell sometime interdifferentiation you are doing. Some people will follow interdifferentiation because that case if you place also A here, A to B, A, C, everywhere distance same. Okay, that is also you can do, but my preference will be go normal matching will do better. Normal matching also you can do like this. Okay, so some book interdifferentiation will be there, or suppose you have only A, B, C. A1, B1, C. That time also you can go A, B, C. How will happen? A, B, C like this also you can do. But if you do center, that will be good. So don't tell like it is coming under. Sometimes you will follow interdifferentiation, or sometimes will be the normal matching. It will not come under interdifferentiation or normal matching means a direct connect device you have to place center. Okay, you got clear?
Yes, sir.
Yeah. So any other doubt or we can close? You can ping me in the group. You can ping in the group also. Not that you can ping me personally if you have any question doubt. So thank you.